Hi, Kelsey. How are you today?
I'm good. How are you?
Oh, it's a beautiful Thursday afternoon. Good, cooler weather, sun shining. What could we complain about?
Sure is. You're right.
So, how are things going?
It's good. I did awful on that test, and I know I did. I knew I did before I even turned it in or finished it.
W- Well, Elmira and I were the only ones on for most of the session on Tuesday, and we sort of talked about that. The first test in this class covers a lot of material, right? So
Yes, it did. That's for sure.
I mean, what was it, 5.5 weeks before we took an exam? That's a lot of stuff to
Mhm.
remember.
Yeah, I agree. And a lot of it was me overthinking like the process.
So were you able to
So,
go back through the exam and see what the correct answers were?
yes. Like not on Blackboard, but like with my the questions like from my notes, I went through and like went back over the videos and stuff and realized what I was doing wrong with those questions.
Gotcha. Do you feel more confident now?
Yes, after I went through them and realized what I was doing wrong, I think I could go back and do a little bit better than I actually did.
Very good. Good afternoon. Thanks for joining us.
Hello.
So I did want to sort of debrief a little bit more on the exam, and I hope you've seen my announcement about all of the things being posted for this week. That transformation video, transformation of functions, is like a little over 50 minutes, probably one of the longest ones of the semester. Um, and then exam two is next week. And so it'll be due by midnight on Friday.
I also had a question about that. On our course content, it does show, let me go back and look.
Do you want to
So in
share
the
your screen so everyone that watches this will be able to see?
Actually, it doesn't say it anymore.
Well,
There
I had an
was.
I had
Go
an
ahead.
eagle-eyed viewer. I think their name was Kelsey, and
Mhm.
they sent me an email and said, "Hey, there's some stuff here that is I can't really get to."
That was me.
Obviously, I'm obviously joking. I know it was you, and thank you for catching that. Um, as we go through these units, uh, I've built the course from the sandbox of someone else's course, and so
Uh-huh.
some of their stuff was still hanging out there, visible. And you may see that if you were to look in Unit 3, there's probably still some stuff. So
Okay.
what I've tried to do is label my stuff with video, if it's a video, so I know to hide all the other stuff. And I neglected to do that on this one. So that's
Gotcha.
my bad on that. And I will have a review posted for you here in the next few days. I believe we only have one section next week before the exam. Let's see, pull up my syllabus. Yes, we have inverse functions, which will be the only section for next week. And my goal is for that video to show up midnight on Sunday. Well, midnight Saturday, so you'll be able to view it on Sunday. That way, you
Gotcha.
don't have any delay in being able to do that before the exam. And
Gotcha.
then my intention is for us to spend both hours next week uh, for the co-rec doing the review.
Perfect.
And so that section will consist of coordinates, linear function or linear equations in two variables, then functions, domain and range, increasing, decreasing, operations with functions, and then composition of functions, transformations, and then inverses. We sort of talked about inverses a little bit with the transformations and the different families of functions, but that will be a more formalized version of it. So, any homework questions?
I have 4 that I couldn't. Well, honestly, on this number 2 and number 3 on 3.4, I didn't really. I looked at the first part, but then the second part, I was pretty much lost, and I was looking for some videos, but I really couldn't find any. And then I have 6 and 14 that I needed, but the rest of them are pretty much.
Well, I think we'll be able to work through all of those. So start from the beginning and tell me which ones we need to do, and we'll get working on it. Did I mute myself? No, I didn't. Elvira, what was the first question you had a question on? See if I can find it. Let's see. If I can save that to my clipboard and paste it. And I'll share my screen.
I'm sorry, I thought I was talking all this time and I didn't. But no, I
Well,
understood the parts of it, but I just afterwards, and then I looked at the practice one and it said infinity and all that. So I'm like, okay, yeah, I can't do this.
gotcha. Well, this is one of the questions you had, right?
Correct.
Well, let's just work through it. So we have two different functions. We have f of x is equal to negative 7x squared, and g of x is equal to the square root of x minus 3. Okay, so the first thing we want to find is we want to find f plus g of x. And f plus g of x is where we just add the two functions together. Oops, it keeps trying to not let me write here. Should be able to. There we go. So that's equal to negative 7x squared plus the square root of x minus 3.
Yes.
That's all we're doing there is we're just subtracting adding and subtracting the function.
So,
And then this
okay,
one,
okay.
f minus g is negative 7x squared minus the square root of x minus 3. And then f times g of x, I'll probably need to come over here to have room. That is negative 7x squared times the square root of x minus 3. And I really don't have a means of breaking that up into simpler pieces. You know, you would think that you would want to try and distribute this part into here, but there's not really a whole lot we can do because we're taking the square root of x minus 3, not just x. We can't undistribute across a radical sign. So then f divided by g is just negative 7x squared over the square root of x minus 3. So we've been able to find all 4 of those formulas. And really, I probably should just take these guys and, oops, come on out here. That way we have a little more clarity on what we're dealing with. Okay, so now we want to find the domain of each of these functions. And how do we find the domain of functions? Well, we first want to find the domain of the individual functions. What's the domain of negative 7x squared? What values can x be? What type of numbers can you multiply by themselves? Well, you can multiply any real number by itself. So that means the domain of f is negative infinity to positive infinity. Now the domain of g, on the other hand, for this to be a function and not fail the vertical line test, we have to have that x minus 3 is greater than or equal to 0. Can someone tell me why that's the case?
No, sir. Because it's 0 is greater. Well, because it's a negative number, or
Right, that's exactly right. Don't be afraid to say something wrong. You're not gonna there's that's how we get to right. We have to make some mistakes, but you didn't make one there. What you said was if x minus 3 is not greater than 0, then we're trying to take the square root of a negative number. And for functions, at least, we don't have negative numbers in square roots. So what this really means is that if we add 3 to both sides, x is greater than or equal to 3.
right.
Well, in terms of interval notation, that's the interval from 3 to infinity, including 3, because it's greater than or equal to.
So the answer to that one is the 3 and infinity.
It's just this part right here. This is that's not the answer to any of these four. We're just finding what the domain of our individual functions are first.
Oh, okay.
So when we add those two functions, what is our domain? Well, adding the functions really doesn't change the domain of g, because we still get that same problem. Oops. In this function f plus g, we still get the problem when x is less than, or when x is, less than or equal to 3, or less than 3, excuse me, strictly less than 3. We still get a negative number inside that square root. So the domain for f plus g is the same as g. Oops. It's from 3 to infinity. The domain of f minus g, same old story. That square root of x minus 3 is still in there. So our problem values are still those values less than 3. So from 3 to infinity. What about for f times g? Well, we still have that same function, square root of x minus 3, that's causing problems when x is less than 3. So it's the interval from 3 to infinity, including 3. Now this last one, on the other hand, because we have negative 7x squared divided by the square root of x minus 3, we also get a problem when the square root of x minus 3 is equal to 0. So where would that happen? Where would the square root of x minus 3 be equal to 0?
Would it be negative infinity?
So right now we want to see where the square root of x minus 3 is equal to 0. And the way we find that is by squaring both sides.
Oh.
Again, we're looking in this denominator here. We get problems in this denominator when x, or when that whole part is equal to 0, because then we have negative 7x squared divided by 0, and we can't divide by 0. That's undefined. So what this gives us next is that x minus 3 is equal to 0. And if we add 3 to both sides, that only happens when x is equal to 3. So all of the other values for x that we have for the function g are included. From 3 to infinity, every other number is included, except which value? X equals 3. So instead of with a bracket from 3 to infinity, our interval for this one is 3 to infinity with a parenthesis. Questions about that?
That's a little bit more complicated.
It is, but it turns out the answers to almost all of those are exactly the same.
Yes.
Notice that the domains are almost always this one, this one, this one, and this one all look like the function g.
Yes.
The function with the most restrictions, well, if there were restrictions on f, that would add more. But because there are restrictions on g, any function involving g, whether it's a sum or difference or a product or division or quotient, we're going to end up with problems in the domain. Problems where we can't take the square root of a negative number or we can't divide by 0. Those are the only two major issues that we have with domains. Not just in this problem, but in general. Other homework questions? Elvira, I know you had more.
I know I
What was
did.
the
And I'm
next
like,
one?
I want to let Kelsey talk.
Kelsey, jump in if you want.
Girl, don't feel bad. I'm learning as I go.
So I have, I mean, like I said, I did a lot of them last night and I looked on videos and stuff. So 6 and 14. So, but pretty much, I guess number 2 is exactly what you just showed us now. So 6 and
Okay.
14 was my next ones.
Well, let's do 6 then. I sure love copy and paste if you didn't know that already. That works out so well for this. Okay. So we have f of x is equal to 1 over x minus 9. And then we have g of x is 4 over x plus 1. And then we want to find FOG of x, f composed with g, and GOF of x, g composed with f. What is f composed with g? What does that really mean?
We're finding G first, correct?
So g is the inside function. So you're looking at f of g of x. So
Yes.
you're plugging the function g everywhere you see an X. So it looks like F, except where we have an X, we're going to put in 4 over X plus 1 minus 9. So how can we simplify that? Well, we get 1 over 4 over X, and then we have 1 minus 9, so minus 8.
I make it, I guess, more complicated than what it actually is. I don't know.
Well, we're not done yet.
Okay.
We're not done yet. So we want to get this X out of the denominator of the denominator. And so the way that we can do that is multiplying by 1, a clever 1. And so to get that stuff out of there, we want to multiply by that denominator of the denominator. So I'm going to multiply that whole thing times X over X. And it'll make sense why I'm doing it here in a second. Because what that gives us is an X in the numerator. And then we distribute the X in the denominator to both pieces. So we have X times 4 over X minus X times 8. So we have X in the numerator, that stays the same. And then X times 4 over X, those X's cancel, and I get 4 minus 8X. And this is how you would want to write it. That's the simplified version.
Oh, I'm sorry. That was on mute.
So this one, F composed with G, is the harder one to find, in my opinion. Now, G composed with F, on the other hand, I think is a little simpler. Let's see if I'm right. G of F of X. This time, we're going to take 4 over we would normally put X there, but in this case, our variable, our input, is the function F. So what we'll plug in is 1 over X minus 9. So how does that work out for us? Well, that's the same as writing 4 over 1 divided by 1 over X minus 9 plus 1. And when we divide fractions, we can multiply by the reciprocal, flip the second fraction and multiply. Plus 1. And so what we get is 4 times X minus 9 plus 1. And then if we distribute, what do we get?
Uh, 4x times negative 9 and 4 Just a moment. 36
minus 36 plus 1.
1. Mm-hmm.
So what's your final answer?
Before x minus 30.
35.
5, yes.
Because we're getting 1 closer to 0. So just to rewrite it, f composed with g of x is x over 4 minus 8x, and g composed with f of x is 4x minus 35. And that's your answer for number 6.
And see, that's whenever I would try to, like, I know it's wrong to, but my mind just wants me to simplify that further and find what x is. And I think that's where I kind of messed up on the test too. Is like
So
wanting
like
to
on
go
the first
further.
one,
Yeah,
or on both parts?
like both parts. Like I would want to try to keep going to try to simplify it to where I would find x equals something. So like where it
Right.
says
So
4x minus 35, I would try to get the x on the other side, basically.
So I see that sort of a lot, where you want to get to a solution where you say, I know what this value is. But the problem in a lot of these cases, this being one of them, we have a function of x. There are a lot of different values for x that will give us a function value. So that's sort of what algebra is about, is being able to use variables for unknowns and not have it equal a certain thing and solving for just that number.
Yeah.
Now, there are cases like with linear functions where we're going to solve and x is going to be equal to a specific value. But usually when we're finding solutions like that, we're trying to find where the graph of a line crosses the x-axis. And
Gotcha.
that's not exactly what we're doing in this case. So I get how that can be super confusing. So most of our lives we go through and we're talking about math in terms of real applied math. You know, where you're balancing a checkbook, or you're trying to build something and it works with numbers and tangible things. And now suddenly in algebra, we're trying to look at the abstract and sort of take a 30,000-foot view of the relationship between two different variables, things that we
Yeah.
don't have a concrete hold on in the way that we would with, finance or
Mm-hmm.
other applied areas.
Yeah.
I get it. I get it. All right. Other questions?
I had 14.
14. Okay. I'm excited about this one because I love finding the equations of lines. Oops. My screenshot didn't work as well as I had hoped. There we go. Okay, so in this example, we want to find the equations of the lines that pass through the point 8, 2, and are both parallel and perpendicular to the line with the equation y plus 4x is equal to 6, excuse me. So where do we start here?
So I tried, and I don't know. This is probably why I'm at it. I tried to plug in, like the 8 and the 2. I try to plug it into that y and that x. So I put that 2 where that y is, and that 8 where that x is, and I try to solve it that way. And that's probably not.
And you probably found
I
that
don't know what
6
I
is equal to 6. Well, you should find that if you plug in 8 for x, so let's do it. Let's plug those in. You should get 2 plus 4 times 8. Well, actually, we're not going to be able to find. You're not going to be able to get. That's not on that line. That's the problem. Is you're not going to get anything meaningful from this because the lines we're looking for are parallel to this line here and perpendicular to that line. So this point is not even on this line.
Yes, I figured.
So
I'm
what
like,
we
okay,
need to
that's nothing there.
Okay, so the first thing I want to mention is that we're looking for parallel and perpendicular. Parallel means we're looking for a line with the same slope as this guy. And then the perpendicular, on the other hand, we want negative, I want to write that out, negative reciprocal slope. Okay, so this equation of this line, y plus 4x equals 6, we need to write that in slope-intercept form. Line, which is y is equal to m times x plus b, where m is the slope and b is the y-intercept. Okay, so what we have, the line we have is y plus 4x is equal to 6. How do we get that line to be y equals something?
Moving that positive 4x over.
Absolutely. We subtract 4x from both sides to get y is equal to negative 4x plus 6. So the slope of a line parallel to this one is what?
That
How would you be
4.
parallel?
Oh,
Negative 4. Very good. No, that's right. Absolutely. And then the slope of a line perpendicular is what? M equals
Is it positive 4?
not positive 4, but positive 1/4. So if we have negative reciprocal means you flip it and you change the sign. Really what it means is that if I multiply the two slopes together, I get a -1. And that's for perpendicular. Okay, so we now have the slopes of both lines. So if we're going to find the equation of a line that's parallel, and we have a point on the line, what's our point on the line? The point that we know that's on our line is the point 8, 2. I think my Apple Pencil has died.
Yes, 8, 2.
No, it's not died, but there we go. It's still, now it wants to write. There we go, 8, 2. So we use the point slope formula, which is y minus y1 is equal to m times x minus x1. Okay, so we can plug in that point 8, 2. So we do y minus 2 is equal to negative 4 times x minus what? 8? You agree with that? For
I
parallel?
do. Mhm.
Yes.
What else do we have to do to
Would
get it
you
in the?
would you start distributing that -4, the -4 to the
You know,
x?
you can, but all you're asked to do is give it in y equals format. So how do you get y equals from this equation?
Move the 2.
We add 2 to both sides. So we get y is equal to negative 4 times x minus 8 plus 2. Now, if you were asked, excuse me, to write it in slope-intercept form, then you would need to distribute it. Okay, what about a perpendicular line? Well, it's the same thing. Y minus 2 is equal to our slope, which in this case is 1/4, x minus 8. And then how would we solve for y?
Move that 2 over again.
We move the 2 over. So y is equal to 1/4 times x minus 8 plus 2. Now, if I did want to put this in slope-intercept, so if asked to put in slope-intercept, distribute to get y is equal to 1/4 x minus 8 times 1/4, which is 8 over 4, or 2, be 1/4 x minus 2 plus 2, which would be just y is equal to 1 over 4x. Questions about that one?
No, it's just a lot of steps to remember.
Well, the big things, the big takeaways here, and I'm going to highlight these in green: negative reciprocal slope for perpendicular, same slope for parallel, and then this point slope formula. Those are the big takeaways in my opinion. Because that will work in all of the cases. If you're given a point and you're trying to find an equation of a line that's parallel or perpendicular to the lines you're looking for, all you need is a point, the equation, and whether it's parallel or perpendicular. Highly recommend trying other examples of this too. Any other questions? These were good homework questions. I'm hoping that people will come through and watch this afterward, because I think these are some of the more complicated questions, and it's like getting an extra lecture video to be able to see examples worked.
I totally agree. I mean, like, I honestly, I couldn't even find any on YouTube that would help me with that. And I was looking and looking. The other ones were pretty much easier. These were, to me, they were more complicated.
For sure. I agree. I mean, we've done what, 1, 2, 3 examples, and it's taken us 45 minutes to do it.
Yes.
Yeah, I actually ran out of time on the exam. I had 5 more questions left, and I ran out of time.
And that's, I think for this next exam, I think I'm going to give a significantly longer amount of time. I mean, if you're working through the question, you shouldn't be penalized because it takes longer. I just don't see any reason to do that, especially after hearing that there wasn't enough time. I don't want to do that again. So
well, I appreciate that.
I will make sure that you have additional time.
Perfect. That'd be awesome. Yeah, because it actually takes me, like, if I'm truly trying to understand it, it does take me quite a while to actually work through the problem and like do step by step how we were doing on like your videos and on these meetings and stuff.
Yeah, I felt like I really wasn't prepared. I mean, it was just a lot of material to remember. But I agree.
Well,
with
and
you.
I can only
more time would have, but for me, I don't think not even time. I mean, it was just a lot of stuff to remember for me.
Right, and I agree. That's a lot of content for one test, and that's why this one is a little bit shorter, less time between exams, and I'll make sure you have more time, and we'll review pretty heavily next week, and move on. I appreciate you both being here. I can tell you that participating in the way that you have will significantly help you when it comes to outcomes on the test. Without a doubt, I've seen everyone else's tests too. The ones that participate in these co-requisite sessions, if they're able, you do better because you have more, not just one-on-one time, but you have more examples that you see.
Yeah.
So I appreciate you attending, and I will see y'all on Tuesday.
Perfect. Thank you. Have a good weekend.
Y'all too. Be safe.
Thank
Bye-bye.
you. You too. Bye.